The Pythagorean theorem is a fundamental principle in mathematics. It describes the relationship between the sides of a right-angled triangle. This theorem states that in a right-angled triangle, the square of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the other two sides. This theorem is usually expressed as the equation a squared plus b squared equals c squared, where a and b represent the lengths of the two shorter sides, and c represents the length of the hypotenuse. This simple equation has had a profound impact on mathematics and various other fields. Pythagoras, a Greek mathematician and philosopher who lived around the 6th century BC, is often credited with the theorem's discovery and the first proof. Born on the island of Samos, Pythagoras traveled extensively, gathering knowledge and establishing a school of philosophy in Croton, Italy. Pythagoras and his followers, known as Pythagoreans, were fascinated by numbers and their properties. They believed in the mystical significance of mathematical relationships, seeing them as expressions of universal harmony. While the Pythagorean theorem bears his name, evidence suggests that the theorem predates him, known and used by earlier civilizations. Long before Pythagoras, ancient civilizations had already discovered and utilized the principles of the theorem. Evidence suggests that the Babylonians, around 1800 BC, were aware of the relationship between the sides of a right-angled triangle. They recorded their mathematical findings on clay tablets, some of which show calculations that align with the Pythagorean theorem. Similarly, ancient Indian mathematicians around the 8th century BC independently developed their understanding of the theorem. Known as the Baudhayana theorem in India, it was recorded in the Baudhayana Sulba Sutra, an ancient Sanskrit text on geometry. The text provides a list of Pythagorean triples, sets of three whole numbers that satisfy the equation a squared plus b squared equals c squared. The Pythagorean theorem has been the subject of numerous stories and anecdotes throughout history. One such story claims that Pythagoras offered a sacrifice of oxen to the gods in gratitude for the theorem's discovery. However, this story is likely a myth, as the Pythagoreans followed a vegetarian lifestyle. Another intriguing anecdote involves the discovery of irrational numbers. The Pythagorean theorem, when applied to a right-angled triangle with two sides of length 1, results in a hypotenuse with a length of the square root of 2. The discovery that the square root of 2 cannot be expressed as a simple fraction challenged the Pythagorean belief in the absolute order of numbers, leading to a crisis in their mathematical worldview. This discovery paved the way for a deeper understanding of numbers and the development of irrational numbers. The Pythagorean theorem's influence extends far beyond the realm of theoretical mathematics. Its practical applications are found in various disciplines, including surveying and navigation. Surveyors use the theorem to determine distances and heights, while navigators rely on it for triangulation and map-making. Construction and engineering. The theorem is essential for calculating lengths, angles, and forces in construction projects, from building houses to designing bridges. Computer graphics and image processing. The theorem is used in algorithms for rendering three-dimensional graphics, determining distances between points in space, and image recognition. These are just a few examples of how the Pythagorean theorem underpins numerous aspects of our technological world. The Pythagorean theorem is a cornerstone of Euclidean geometry, a system of geometry based on the axioms of Euclid. Its importance in mathematics cannot be overstated. It is used in countless proofs and derivations of other geometric theorems and formulas. Furthermore, the theorem has inspired the development of new mathematical concepts and areas of study. For example, the study of Pythagorean triples has led to advancements in number theory. The theorem also has connections to trigonometry, where it forms the basis for the Pythagorean identities, relating trigonometric functions to the sides of a right-angled triangle. The Pythagorean theorem has played a crucial role in the development of architecture and engineering throughout history. Ancient civilizations like the Egyptians and Greeks used the theorem to construct monumental structures with astonishing precision. The pyramids of Egypt, for example, are a testament to the ancient Egyptians' understanding of right-angled triangles and their ability to apply the theorem in their construction. In modern architecture and engineering, the theorem remains an indispensable tool. Architects use it to calculate roof slopes, structural supports, and the overall stability of buildings. Engineers utilize the theorem in bridge design, road construction, and the development of various other infrastructure projects. The theorem's principles ensure structural integrity and safety in countless structures around the world. The Pythagorean theorem's reach extends even into the realm of modern science. Physicists use the theorem in various branches of physics, including classical mechanics, where the theorem is used to calculate distances, velocities, and forces in 2 and 3 dimensions. In electromagnetism, the theorem helps determine the magnitude and direction of electric and magnetic fields. In quantum mechanics, the theorem is employed in calculations involving wave functions and the probability of finding particles in specific locations. The theorem's appearance in such diverse scientific disciplines highlights its fundamental nature and its role in describing the underlying principles of the universe. The Pythagorean theorem, a timeless mathematical principle, continues to hold immense relevance in the 21st century. Its applications continue to expand alongside technological advancements. In the age of computers and big data, the theorem plays a crucial role in fields like data science and machine learning, where algorithms utilize the theorem for distance calculations, data visualization, and pattern recognition. In artificial intelligence and robotics, the theorem is used in robot navigation, computer vision, and the development of autonomous systems. As technology continues to advance, the Pythagorean theorem's applications will undoubtedly continue to grow, solidifying its place as a fundamental principle in mathematics, science, and beyond.